going too, and I was like, that makes me wonder.
Okay, so we're recording. We're picking up here. I'm not going to repeat everything I just said, just kind of summarizing last week. But solving graphically. The key, what I just asked, is x squared minus 4x plus 1. Does that factor? No, you can't multiply to be 1 and add to be negative 4. Okay? Yeah, there's always quadratic formula, but here's the deal. If you go quadratic formula, you're going to get decimals. So, you'll notice this section says to solve graphically. Okay? To solve by graphing, we're just going to go straight to the calculator. We're not going to factor or anything like that. And we're going to look for where this is going to cross the x-axis instead of factoring. Now, when we looked at the graphs of the ones we factored on Friday, remember, we noticed that they cross the x-axis the same place we factored, right?
Yeah.
So we're just kind of shortcutting that because these numbers aren't going to work nicely. So, go ahead. Plug it back in here in a minute, but go ahead and graph. Now, what are you graphing?
Oh my gosh, my battery is low too.
When you graph this,
Mine is flashing.
Red light.
we're going to graph y equals x squared minus 4x plus 1. So, when you go to graph, first of all, make sure your equation is already equal to 0, or in this case, greater than or equal to 0. So you are graphing the y equals version of that.
Do you have 2 chargers or just one? Yours will last like a week. Mine lasted all last week.
You're going to be okay for right now.
On the
Let's
battery?
get through with this lesson.
Mine
Yes.
doesn't even have the flashing red light.
You're okay for right now.
Okay. I've got 2 chargers in my locker. I haven't looked at either. They're just kind of chilling in the pocket. Just 2 of them taking.
There we go. Okay. So I am graphing, what am I graphing? X squared minus 4x plus 1. I'm going to do a zoom 6. I did a zoom 6 to get a standard zoom screen in, yes. And I'm trying to think which way I need to move my brightness. There we go. Nope, it's that one I want. Okay. So your screen looks similar to mine if you've graphed it correctly, yes?
But I wrote it down, it didn't work.
Okay. Now, in order to figure this out, we are asking ourselves, what does greater than or equal to 0 mean?
Above.
Yeah, we're going to be asking ourselves, where is our graph above the x-axis? Now, to ask ourselves where the graph is above the x-axis, what do we have to know? What do we have to know very precisely here to answer this question? What are we going to have to know to give our final answer? Our x-intercepts, yes? Okay, I mean, I can tell you approximately what they are. That cursor's kind of in the way there if you're trying to, you know, move out of the way there. Actually, I'll just turn. There we go. I can tell you approximately what there are. There's one that's between 0 and 1, yes?
Yeah.
Yep.
And there's one that's between 4 and 5, yes? So there's one that's 0 point something, or is it between
3 and 4.
3 and 4? Okay, sorry. I saw the look on Connor's face. I'm like, I probably counted wrong. Okay, and look at the answers. Okay, so there's one that's going to be 0 point something, and there's one that's going to be 3 point something. Is that accurate enough? No. So, hey guys, how do we find those zeros accurately? I gave the word away. I said the word I didn't want to say. How do we find zeros? Remember there's that little place to find zeros?
I wrote down what?
Go back to the white screen.
I wrote down the right thing
Okay.
and I crashed it. And it's different than everybody
Okay.
else's.
Zoom 6.
It's just Jamie, so I
Go
should
back to the standard Zoom screen. The screen was really zoomed out. Now it looks like mine, yes?
Yeah,
Okay, guys, so
funny.
in order to progress here, we need to find our x-intercepts. And I'm going to write a little note in case you're still trying to remember. But in order to find x-intercepts, what's the word I accidentally used? You're finding your zeros, yes?
Yeah.
And the reason I say accidentally because I wanted to make you guys think about it. But where do we go in? We go into that calc menu, right? So you go into second calc, and then you go into zeros. You remember how to do this? This is a necessary skill. If you're still struggling with this, now is the time to get it figured out. So I'm going to do second calc, which is the trace button. I'm going to go down to number 2, which is 0. Now, if I'm going to find my smaller one first, left bound. My left bound means this cursor needs to be to the left of where we cross the x-axis. So in this particular instance, my left bound is going to be above, if you will. But it's to the left in terms of x values. I hit enter. Now it's asking me right bound. So I arrow to the right. I go past my x-intercept, so the past point runs across the x-axis. Happens to be below because my graph is decreasing. I hit enter. Guess. We're going to go back. Honestly, the guess isn't a huge issue. It's not a mandatory, it's not going to mess things up most of the time. And I take my guess back to the approximate area, and I hit enter. I know this is a 0 because A, it says the word 0, and my y value is 0. And so what is my first 0?
0.267.
Okay. What he said, right? 0.267 something, something, something. I have 2 decimal places in my notes. So I have approximately 0.27. Did you guys get that one?
Yes.
Okay. Now we're going to repeat the process to get the next one, correct?
Yeah.
So second, calc, 0. Now for my left bound. Now my left bound has to be somewhere left of that 3.0 number. Notice, like right here, my left bound is 3.03. Well, yeah, that makes sense because it's maybe closer to 3 for the actual answer. Hit enter. Right bound. So now I have to go past that. So it's probably going to say 4 point something, which it does. My guess, I'm going to arrow back. Does your other answer match my other answer?
No.
Yep. 3.7320508.
Yeah, that's what I got. I'm really charging with math.
I'm writing down 3.73. Okay. Now, here's the deal, guys. We need to come up with answers. Less than, greater than type stuff. I'm going to sketch a graph here. There's my attempt at a graph. We already found these pieces, correct? That's approximately 3.73. That's approximately 0.27, right?
Yeah.
Now, where are we looking here? Where does this graph matter? Where the graph is where? Greater than or equal to 0, which are values that are above the x-axis. Hello?
I get the numbers.
Okay. I haven't had any other reported issues with SOGs today, but okay. Okay, bye. Okay, so I think I was saying greater than or equal to means we're looking for where's the graph above the x-axis, yes? So above the x-axis, we've got this piece here, yes? And it's the two, we're in two pieces on this one. Which means my answer is going to be in two parts. Because it's going to be x is this, or x is this. Now, have you figured out how to work this? And this is where, I don't know, do the vertical lines help or not? Maybe not, because I didn't change colors on this one. But this 0.27, the values that are above the x-axis, where are they in relation to x is 0.27? And that's where my x values are less than 0.27, because over here my x values are negative, yes?
Yes.
Those are numbers that are less than 0.27. So part of my answer is going to be x less than 0.27. You think I should say less than or equal to?
Yeah.
Yes, because my original problem had equal to in it. Now, since we're doing two pieces, this is an or statement. Okay, so we had to the left of 0.27, if I think about a line through 3.73, where are these values? They're greater than. They're to the right of that 3.73 line. So this is x greater than or equal to 3.73. Okay? Now, again, we're supposed to be doing interval notation, yes? And I don't know if this is going to help or confuse, but if you think about this, 0.27, less than or equal to 0.27, that is values to the left, yes? So if this visual helps, greater than or equal to 3.73, that is numbers to the right of 3.73. Okay, so if we're doing interval notation, where does my first interval start? When it's shading off to the left, that's negative infinity, yes? Shaded up to what? That's the 0.27 with a bracket. The union symbol, which is a U. Or, what is the other one? This shading starts at 3.73 with a bracket and goes off to infinity. I don't know why I did not squeeze that in very well. Eesh. That's really messy. Sorry. Okay, questions on that? It's really kind of a follow-up from Friday, isn't it?
Yeah.
Okay, example 6 real quick. Solve x squared plus x plus 2 less than 0. So what's less than 0 mean? What are we looking for? Less than 0 means I'm looking for where my graph is below the x-axis. Okay, so you're going to go ahead and graph. It's already equal to 0, so to speak. We're going to graph y equals x squared plus x plus 2. Okay. Thoughts? Oh. If your graph looks like mine, it's never touching the x-axis, is it? Okay. So that means my answer is one of two things. Since my graph never touches the x-axis. What would you guys call the answer here? I mean, where are we looking? We're supposed to be analyzing where our graph goes below the x-axis. What do you notice? It doesn't go below the x-axis. So what's my answer? I just say no solution. Okay? My graph is never going below the x-axis, so this is no solution. Okay, so graph never goes below the x-axis. Now, I said it could be one of two answers. The other option, what if the question here had been, when is this graph greater than 0? Is my graph ever greater than 0? Does it ever go above the x-axis? Yeah, it's always above the x-axis, isn't it? So the opposite of no solution is all real numbers, negative infinity to positive infinity. So if you have a graph that's always in the place you're talking, then it's everything. Because all those answers, that whole parabola or whatever, is above the x-axis. Okay? So, watch your directions on homework. Sometimes they will say, solve algebraically. So I want to see some algebra written down then. Some factoring. Sometimes they'll just say solve graphically. Do you have to show me algebra then? No, if it's solved graphically, you're looking at the graph and getting the values you need. Okay. Got it? Okay. Do I dare say let's talk a little physics?
No.
Sorry.
We're good.
We don't need any.
No, we're done.
Okay.
I see you get that.
So, when we talk about parabolas, which is what we're talking, we were just talking about the quadratics, the parabolas, there is a big connection between quadratics, so parabolas, and projectiles. So in this case, projectile motion. Okay, so shooting an object up in the air. And when you shoot an object up in the air, what happens?
Eventually.
It eventually comes down, right? So, with that in mind, okay, given that an object is launched vertically from a point S of O, or I sometimes call it S naught, S0, whatever, feet above the ground with initial velocity of V naught, or V of O, feet per second, the following is the equation for the position of the object t seconds after being launched. So, S of O is your feet above ground. Initial velocity is V of O. And this is the equation for the position of the object, and it's t seconds after being launched. So we're going to use this setup in our following problem. Okay? Notice V naught, or V of 0 is going to be initial velocity. S naught, what do I want to say? I guess I didn't, given an object is launched vertically from a point, so this is your initial position. Okay, so initial position, initial velocity. A projectile is launched straight up from ground level with an initial velocity of 288 feet per second. When will the projectile's height above ground be 1,152 feet? And when will the projectile's height above ground be at least 1,152 feet? So we're going to start with, we were provided an equation earlier, yes? S equals negative 16 t squared, plus V naught of t plus S naught. So let's fill in what we know here. In other words, we need to know a V naught and an S naught, or initial velocity and initial position. So S equals negative 16 t squared. Are we provided an initial velocity? What's my initial velocity? Yeah, read right there, yes? It says initial velocity. So 288 times t plus S naught. So that is your initial position. What is my initial position? So initial velocity was 288.
0.
Why 0?
Because the ground level.
Yeah. Guys, ground level. Ground level is saying you're launching from a height of 0. You're not on top of a building, launching from the top of a building. You're launching from the ground, so you are at 0. Okay. That is the equation we are working with throughout this entire problem. Now, obviously, I put the plus 0 on there for looks. Am I going to need to leave that plus 0 on there? No. It's just on there for looks for right now. First question. When will the projectile's height above ground be 1,152 feet? What am I going to have to do here?
S.
Okay, yeah.
You just subtract the number to sum.
Yeah. Projectile's height above ground. So we're trying to find the position. So this is S. So basically we're going to set our equation equal to 1,152. So I'm going to say negative 16t squared plus 288t equals 1,152. Yes, I dropped off the silly plus 0. Now, how are we going to go about solving this? Okay, and in order to factor, we need to subtract 1,152, which I know Kylie had already said earlier. So if I subtract my 1,152 over, I now have negative 16t squared plus 288t minus 1,152 equals 0. Now, I know Connor used the word factor. As you look at that, that looks ugly. A neat little thing happens here. There is a wonderful GCF that will make this problem 100% easier to work with. Can't go that big.
16.
Okay. All three values divide by 16. And at that, since the first number is negative, what I'm going to suggest is take all three numbers and divide by negative 16. Well, technically, all four numbers. Because when you divide an equation by a number, you have to divide everything on both sides, yes?
Yes.
Now, this will make, that's currently a pretty ugly equation, isn't it? But it actually gets pretty nice. Once you divide everything by negative 16, what do we end up with? T squared minus 18t, and that's going to become plus 72. There's no fourth.
I did that divided by 288.
Get off the 288.
No, I'm
He is stuck on this 288. No.
still halfway.
He's got beat.
Okay, we're divided by 16, not 288. Okay. Is that more factorable?
Yeah.
And yeah, you can do quadratic formula, but it does actually factor. When I hear what multiplies to be 72, I have one set of factors that immediately come to mind every time. Now, there's another set of factors that comes secondly, but what multiplies to be 72? See, that's my 12 and 6 is my second answer.
I thought 8 and 9. Yeah, I thought
8 and
9.
9. Yeah.
But then it doesn't have to be 18, so you have to pick something else.
Yeah, that's true.
I already tried.
I'll be honest, I had 8 and 9 in my head as the final answer here. So, it's a morning for me too.
It's been a long
Okay,
It's been just
So,
a long week.
t squared
Just like
breaks into t and t.
Friday.
multiplying to be 72 and adding to be 18. My goodness. Minus 6 and minus 12. I was all ready to lead you guys astray. And what do we do, of course, with both parts here? T minus 6 equals 0. T minus 12 equals 0. We have solutions of 6 and 12, correct? Now, with that in mind, the question was, when will the projectile's height above ground be 1,152 feet? I have answers of 6 and 12. Are they both legitimate answers? How? How can it be that height twice?
Oh, what's above ground at least. And then just
Are you gonna have to play it all back in?
No.
Oh, okay.
I'm just trying to. So think, projectile motion. What's this object doing?
Go down.
It's going up. And then what?
Oh, and then it's coming back down.
It's coming back down. So assuming this object goes higher than 1,152 feet, could it possibly hit 1,152 feet twice?
I'd say so.
Yes. And so here's my visual for you. This is a quadratic, yes? It was a parabola. The negative out front means this is what kind of parabola?
It's upside down.
Upside down parabola. And so the idea here, you've got a parabola that looks like this. At some point, and this isn't going to be drawn to scale, but there's 1,152. So what this is saying that at 6 seconds, it's on its way up. And then it goes up, it hits some top height here, and then what's it saying over here?
Comes back down.
At 12 seconds, it goes back down. Okay? So that's the idea of what we are looking at. So when will the projectile's height above ground be 1,152 feet? And we can say, debating what I want to say here, at 6 seconds and 12 seconds. And if you want, you could even, it went up at 6 seconds, right? And it was coming back down at 12 seconds. And I don't think, 6 and 12 are essentially your answers there for the first question. So, now we technically have one other question to answer. But mathematically, we don't have to do anything else. Mathematically, we're done. We just have to answer this question. So put it into the sense of what we've done. My other question is, when will the projectile's height above ground be at least 1,152 feet? What do we mean at least? When we talk at least, we're talking greater than or equal to. So when will the height be above 1,152 feet?
Between 6 and 12.
Between 6 and 12 seconds? Because when is it above 1,152 feet? Right up here, yes? And so our answer for the second part is just, if I put it in words, it's between 6 and 12 seconds. If we do interval notation, what? It starts being above at 6, and it ends being above at 12. So we can say 6 to 12, or 6 less than or equal to t less than or equal to 12. If we stick with interval notation, it's that one there. Because at 6 is where it goes up. It's above, above, above. At 12 is where it comes back down. Okay. Not quite as much work time as I'd hoped. We had a slow start in class today. Slow start issues. But you do have a little bit of work time. You got 10 minutes, right? Use it. On page 57, 58, whatever you want. It's
Sorry, what would the negative 6 teach to represent?
gosh darn it, just a second. I heard you. I'll answer your question here in a moment. Or I'll try and figure out what you're asking and answer it here in a moment. Okay, 2 through 26 evens. And 33 and 34? Okay.